with Optibelt over here in our Chicago location, and I've been with Optibelt for 2 years. And today we're just going to go over a couple of belt basics and then some tools to help install and maintain your belt drives, and some tips and what makes the belt drives last longer. So essentially how to do this correctly and how to get the most out of the time and money you actually put into installing and purchasing these products. If that's it, Lynn, should I get started?
Yes, please.
Alrighty. So first, we're going to start with the on screen. First, we're going to start with belt basics. So I realize I'm speaking to an audience that has a lot of questions about what the different types of belts are and what the difference is. So we'll go over that first, so the rest of the sections on installation are a little less confusing and you kind of know the nomenclature that we use. So the biggest question we typically get is, what is the difference between a wrapped belt and a cogged belt, or a normal looking belt, as some would say, and then the one with the teeth on it? First, you have wrapped belts, and these were the original belts invented way back with Gates, and they are the same rubber core with a tension cord, except the difference is they have fabric on the outside. Ours have 2 layers, some have 1, but most you'll find in the industry have 2. And now what this does is that fabric helps protect the belt from any sort of grit, oil, and wear that's in the sheaves. So this is very helpful in sandy environments and ones where you have a lot of contact with anything that could damage the belt or the sheaves. It acts as a layer of protection and also helps dissipate heat. In addition to that, one of the advantages of these wrap belts is that it can slip during torque spikes. So if you have a rather old, this is mostly for if you're dealing with a gasoline engine where the torque can go up and down and you can have changes in the load. Not so much like fans in HVAC industry. But what that fabric does is it allows it to slip, and the fabric takes a little bit of damage, but not a lot. Thus letting the belt last longer in applications where this happens. On the other hand, you see a lot in the HVAC industry, cogged belts. The difference with these is that they are they're raw edged, they do not have fabric, so it's raw rubber on metal contact whenever they're running, and they have these teeth in them. And now what those do, and why they're there, is that they increase the bending capabilities of the belt. So whenever you have a rooftop ventilator, or you have an air handling unit, or anything that is in a very tight space, you can't have these larger pulleys to extend the belt's life, so you have to make a belt that is more flexible to fit around these pulleys. What that does is it removes some of the material where most of the bending stress and heat buildup happens. Because a lot of the heat buildup, the biggest enemy to belts is heat. And one of the main ways this happens is you have bending stresses, and then after a while the belt essentially overcooks and starts to fail and crumble, which I'm sure a lot of people have seen. But the other advantage of cog belts is because you have this raw rubber on sheave contact, it has a higher friction and thus can transmit more power than a wrapped belt. So that's why they're usually perceived as more efficient. They're not necessarily more efficient, they just slip less, which can be both good or bad. So over a large drive, you would actually have less cog belts because they can transmit more power per belt. Now, the downside of cog belts is for this additional power transmission and friction, there's more wear in between the actual pulley and the belt. If the torque were to spike, instead of it slipping, now the rubber is actually taking and polishing away part of the pulley every single time it moves. Whereas the wrap belt, the belt takes most of the damage and your pulleys last longer. So it's kind of a pros cons of these are the 2 major types of belts you see in the market, and why you choose one or another. Now, a lot of people also ask about profiles. You see a lot of different profiles here, but you can kind of take away what categories are. You know, you have the ones that are just letters, and these are the original belts invented when the V-belt was first invented by Mr. Gates. And they are not as tall in profile, and they still stick around a lot because they're also more flexible than the other profiles. The other one in the English size, so the A, B, C, D, and E, these are all imperial sizes. They're inch-based, and they originated in the U.S. The 3V, 5V, and 8V, these are what are called wedge belts. So you can see from the picture they have a little taller of a profile. And this gives more area on the side for it to transmit more power. So again, this came on later when they realized, and they finally had the technology to make rubber a little better and actually be able to sustain this profile. And what that stands for is the 3V is 3/8 of an inch, the 5V is 5/8 of an inch, and the 8V is 1 inch on the top. So that's what those mean. And again, these are based in English units, so you'll find them in, 57 inches, 48 inches, and nothing in millimeters. And on the other side, the metric equivalent to the 3V, 5V, and 8V, so these so-called wedge belts, are the SPZ, SPA, SPB, and so forth. And these ones will be in metrics. You'll see them in 2,000 millimeters, and you will only really see them on equipment you've purchased from Europe. Now, in terms of what belt can fit where, most of these we would not suggest putting an SPB and a B, just because the B is similar, the profiles are not. It is rubber, so it will fit, but it is not suggested because it will not last long. So it's just kind of, you all will see these letters, you all see these numbers, and that's kind of what they mean. So in terms of Optibelt, in one of our products, we have our standard wrapped and cog belts that Dreisilker sells, and then they also sell the HVAC power. And so this is a wrapped belt, but it has all the advantages that a cog belt has in terms of flexibility. So it has a special fabric on it and has a special cord, so it doesn't really go for the high power transmission as much as it goes for long life and temperature resistance. These are mostly found in the mushroom fans and rooftop ventilators, some places that can be somewhere you can't get to and replace the belt very often. So these are ones we had specially designed for the US market with HVAC. The biggest advantage is you see these A, 4L, and 5L and B profiles. These ones are dual labeled, so you can reduce your inventory and have just one belt that covers two sizes that a technician might not be able to know if they're cross-compatible. So if you have a lot of rooftop ventilators, this is a good solution, although it is a premium belt. So I'll get on to the core of it, where you have the actual installation and maintenance. So the biggest question is always, how long are my belts supposed to last, and are they lasting as long as they could? So theoretically, in the laboratory, under perfect conditions, a belt should last 3 years. Now, most people would realize that rarely ever happens. And from what we've seen, about half of those belts last 1.5 years, and only 20% of those belts actually get to 3-year lifetime out in the field on real machines. So the reason for this, 70% of it, from what we've seen, is service tension and installation issues. So you install it with too low of a tension, you install it improperly, you install it with a screwdriver and you damage the belt, or you just didn't have time to tension it properly and align the pulleys. This causes extra heat, this causes extra wear, the belt fails early. And then the other 20 is, again, I was talking about heat, dirt, oil. Some belts are better with it than others, but they still lead to premature failure. So that's about 20% of it. 10%, under 10% is drive calculation, meaning you don't have enough belts or you have too many. Another one being old belts, and then quality is only in the single-digit percentage. So what we'll go over is tips to how to increase the life of your belt. So they always say use optimal drive dimensions. So this is, don't put on fewer belts than you need. If your drive application needs 4 belts, 4 need to be on there. If you put in any less or you mix old and new belts, then you get unequal loading, and then they'll all fail early. So most of the components come with installation manuals, or at least the taper bushings and pulleys should have something from the manufacturer to tell you how to install correctly. follow those. And when you do install them, or when you do replace your belts, some people use a 2x4, some people use a string. We have a fancy laser tool, but try to align the sheaves, because if the belt's not going in and out of the sheave aligned properly and at an angle, it does more wear and tear, and the belt will fail early. And the biggest one is just make sure they're at the correct tension, not too high and not too low. And here's to show the effect that temperature has on the belt. So an increase of temperature of 20 degrees Fahrenheit can reduce the belt life up to 50%. So if you start going over the maximum temperature of the belt, for every 20 degrees, it's another half and another half. So it starts failing very quickly if you get an area that's way too hot. So we'll quickly go over some of the tools that Optibelt offers, and then you've probably seen similar ones on the market from our competitors. So safety first. You always lock out and tag out any sort of electrical equipment. You do not want anyone getting injured. These drives have a lot of energy, the basic safety precautions. So here are a picture of the 4 different tools that we offer. And we have one giant service kit that we offer, although that's usually not financially feasible for most people. I'll tell you which one is probably the best option for most people. So in this box, or at least in one of the boxes, comes a V-groove sheave gauge. So another question is, a lot of people wonder, when should they replace their pulleys? We say anywhere from every 3 to 5 belt changes, you should probably be changing your pulley. But that's not always financially feasible, and sometimes you need to just visually inspect it is the best way. So they have something called a V-groove sheave gauge. What this does is it has a plastic profile of what the groove is supposed to be like under ideal conditions. And you take this and you put it in the groove in multiple places, like shown in the picture, and you shine a light behind it and you see light leaking out. And if the sides of the pulley are uneven, they show signs of being polished, so they're very shiny, or they have uneven wear, it's about time to replace your pulleys. Because when the belt comes in contact with that uneven wear, it will get damaged as well over time, and it'll fail early. Another item we talked about was alignment. So we offer a laser pointer kit, and what this does is it's an item you can put on one pulley, and then you have 5 targets to put on the other pulley, as many as you need, and use it to line up your pulley to make sure that they're perfectly aligned. It's a little more complicated than a 2x4 or a string, but it's definitely useful for large drives. So it shows you if, maybe the pulley needs to be moved in on a shaft a little bit, if all the targets are low. And it shows you if you have some angular misalignment, so maybe something on the mounting or with the chassis or with the actual bushing itself. Now we'll get into tension. So tension matters because this is where you get your efficiency from. This is where belts either fail early or the motor starts drawing more power than necessary. So you go over tension, it starts drawing more power. You go under tension, it slips, and then it does not transfer the power that it needs to the fan or whatever is being attached to the motor. So one of the tools we have that most people get is the OptiCorrect. This is one that Dreisilker does offer. There are 4 of them for 4 different tension range. And they come in a kit of, you can buy them individually, or you can buy them in a box. And this is very simple. You put your finger in it where you see the little loop, and then you press down on the middle of the belt, it clicks, and then you read it off of the gauge. So when that little lever comes up, and then that's the tension that you have in the belt. And then you move the drive in or out to tighten it or loosen it based on what this number is, and then your recommended number. The more precise option we have is called an OptiTT, and this uses either electromagnetic waves or an accelerometer attached to the belt to measure the frequency, which is another measure of tension. It has a nice color LCD in the battery, and this is if you have Most of the people that buy this, they have 80, 90 drives. For instance, one customer I work with has a hospital campus. They have 80 to 90 drives that they check every couple of months. This saves them a lot of time, and it allows them to easily write down and kind of notate, where these drives are and if they start getting close to needing to be replaced. And it shows just the various frequencies that it can do. So the accelerometer is for very large belts and, 500, 600 horsepower drives with massive belts that can be almost a foot wide. And then as you start going up in the frequency, then you have the small belts like the ones on mushroom fans. Now, another question is everyone always wonders where these tension values come from. Where do you get this frequency? Where do you get this pound force? Dreisilker is able to, their salesmen are able to do calculations for you. So the biggest pieces of information they need to be able to do this is the driver and driven RPM. So your input and your output, what's your motor RPM, typically, 1800 or so, and what RPM your fan is running at, and the amount of power it's putting through, either in horsepower, kilowatts, and then either needs center distances, or they need pulley sizes and the belt. So also how many belts you have and what size they are. So you kind of give them the general overall information. And then if you, let's say, have 10 drives, just get an Excel document, write it all down, send it over to them. They'll be able to get you tension information to put in your records. And this is how to make sure you get the most out of it. Now, there is also a handy, with these devices comes a nice little brochure. It's a small little kind of cheat sheet. And you can take the size of your belt, the profile, and the size of your pulleys, and it'll give you an average recommended tension. It's not the best tension for your specific setup, but if you're out there and you really need a number, there's a pamphlet that comes with these that has most of it. And also we'll be sending out an installation and services PDF with this that should have those numbers in there as well. So if you have it in your email and you ever get in a bind and you don't have time to wait for a calculation, you can use these numbers as kind of a general guideline and go back and fix it later. There are numbers where the belts won't fail. They won't be as good as they can be, but they also won't burn out early. And you won't break the bearings. If you're ever wondering what information you need, on the Optibelt USA website, we do have a form under the resources that you can download and then fill out in the field. But most people just use a notepad. So just a couple installation tips. These are issues we see all the time and generally don't recommend is do not use a screwdriver to install the belt. A lot of the times, a lot of these machines, especially on rooftops, are very difficult to fit the belt over the pulley. There's not a lot of room for adjustment, and you usually have to remove some pieces just to do it. So it's very tempting to take a screwdriver and then just push it over into the groove like it was an automotive belt. However, you can stretch or damage the cords, and that belt will not operate like it should, and it will most likely fail early. You can get away with it sometimes, but it's really not advised because you can damage the belt, and you'd be replacing it soon anyways. Also, when you go to measure tension, always make sure you rotate the pulleys before you're measuring the tension. This is more for larger drives, but you have your belts on, and then you want to go and measure the tension. But the belts really haven't settled into the grooves yet. So you just kind of very carefully avoid pinch points, turn the pulleys and get a full rotation in and let that belt settle in. That'll get you the most accurate tension reading. If you want to test it for yourself, read the tension beforehand and afterwards, and it'll change, and not by a little bit, but by something that'll be actually significant. And we'll kind of look at common failures. So these are kind of pictures and descriptions on what can happen to the belt, and then what are the common causes and ways to fix it. So one of the common problems is you have excessive wear on belt edges, and this means that the belt is not riding properly in the pulley. It's either getting up on one side or in some cases turns over completely. So possible causes, again, tension too low, or your starting torque is too high, meaning that belt is jumping out and then the edges are running along the pulley and then it's finally settling back in. And then worn pulleys will also cause any sort of uneven wear on the side of the belt. So most of these are kind of bland. They just say check tension over and over again. But tension is a huge cause for failure. Cuts and splits in the base of the belt, so brittleness, you can see these in really old belts, or it looks incredibly old, or ones that have been in a very hot environment. And this is, when you start seeing these, is usually how people determine it's time to replace the belt. Meaning the rubber's getting old or it's reaching the end of its service life. So possible causes are outside idler, but this isn't applicable to most air handler and HVAC situations, but only some belts can be used with outside idlers. Other ones, the rubber doesn't have the flexibility to bend both ways, both around the pulley and backwards. And what this does is it has extra stress and extra heat, and eventually the belt just rips itself apart. Or any sort of abnormal belt slip. So if your tension is too low, the belt starts slipping, it builds up heat, and this vulcanizes the rubber even further, and then it starts cracking, becomes brittle and hard, and then can't do its job. Or any sort of chemical influences. And then temperature too high. So again, remedies are retension your drive, and then protect it from contamination, and make sure your temperature in there is not getting too high. So it's mostly applicable near gas engines or any sort of exhaust or ventilator fans over kitchens. And then another one, belt swelling or softening. So this causes premature failure of the belt, and this is just oil, grease, or chemicals. If you see any sort of swelling or any sort of blistering of the belt, it's come in contact with some sort of contamination, and the rubber over time will absorb it and then just degrades. And then belt turnover. So one people see a lot. So it's either you have the wrong belt or groove section. Again, they will fit because it's rubber, but it's not advised, and this will eventually happen. You know, if it's a B, it's got to be a B belt in there unless you replace your pulleys. If it's a 3V, it's got to be a 3V. And if your tension too low, or if your pulley grooves are severely worn. So with the tension in the pulleys, again, if it's not all right and lines up, the belt has some play. Let's say you get a torque or you start up or stop the machine, the belt gets some slack, it loosens up and jumps and turns over. And then it'll destroy itself very quickly after that. Then foreign matter in the pulley. So if you get a rock or a nut or a bolt stuck and it pushes the belt out and turns it over. So again, it's tension, make sure your pulleys are good, and you can avoid most of these problems. So common problems, and then some of the solutions we have for them, and why we usually suggest Optibelt. So a lot of people ask about length differences in belts. If you buy the same profile, the same length, like what are the differences? If you don't get a matched set, which is a term used a lot, the lengths of the belts can be different. So one will be too tight and one will be too slack, and then one will fail early, and then the other one fails soon after that. But with Optibelt, a lot of the belts that we sell, we have a length tolerance that's very tight. So you can get a belt from Singapore, from Mexico, and from Germany, and I'll put them on the same machine, different production dates by years, and they should be very close to each other, and you have a lot less problems and a lot more efficiency because now the belts are equally sharing the load. And so an example of this is match set tolerances for B100 can be almost plus or minus an inch over that 100 inches. Whereas for Optibelt, we have plus minus 1/8 of an inch for that same size. And what this means is there's that much less tension difference between two or more belts. And the more belts get on, the more efficiency you lose because of this difference in length tolerance. The way we do this compared to our competitors is we have something where after we produce the belts, we let them cool down and we let them settle. So the cord stabilizes, and then they're all the exact length that we're very close to the exact length that we want them to be, now or 3 years from now. It's a very controlled process. Our belts are not constructed on a mold, or at least our wrapped belts are not constructed on a mold, and that's what gives us these kind of superior tolerances. And that's usually why we push wrap belts over cogs sometimes as well. So the second most common problem is belts not get properly tensioned or retensioned, and preventative maintenance is not done, or people just don't have time for it. Maintenance technicians are very busy, usually running many other things just besides belt drives. So it just kind of goes by the wayside because it'll keep working. So we offer a couple belts that are available through Dreisilker that are maintenance free. So you install them, you run in the drive a little bit, you retension it, and then it's fine for the rest of its life until the belt fails. So that would be our red power belts, and then a new one we have, which is cogged, which is the XE power. And a lot of these should be in sizes that fit HVAC, but these would be more for air handlers or larger. And one of the ways that this shows energy efficiency is we had a plant for a large automotive company that was running many air handlers, and they were looking to save money through saving energy, because everyone is. They were running 4 belts on a drive, and they put us up against a couple of our competitors, but because of our red power belts, which are kind of our flagship wrapped belts, they're able to transmit 50% more power, so they only needed 2. And because of the tension being fine for the entire length of the belt, not needing to be maintained or retensioned, they ended up using a significant amount less power. So I think it was a 6-month period of time, and we used about 30,000 less kilowatt hours, which was about $2,400 over a 6-month period on energy alone. So this was one drive. And now, since then, they've replaced all their drives with this, and they're actually still running. Because with our maintenance-free belts, your preventative maintenance is making sure that the belt is still on the drive, not necessarily that the tension is right. As long as you install it correctly, it keeps going. However, with most belts, you need to retension them every 6 months to a year, or whenever you see some RPM drop in the fan. Another problem is standard belts that are sold fail due to lack of maintenance or overheating. And small belt drives require some very special belts, and sometimes, like mushroom fans and ventilators, force belts to fail early because the pulleys are so small. For that, we created the HVAC power, which has a higher temperature tolerance, is more flexible, and has a little bit of stretch to it so that it doesn't lose as much tension over time. It's not maintenance-free, but it's better than standard belts. And our success story for this is we had a restaurant chain, or a mechanical contractor that worked with the restaurant chain, and they had HVAC units that were failing every 3 to 4 weeks. And they were on a yearly contract, so they were losing money having to go out and replace the belt all the time. So they came to us, and they were asking if we had a solution. So we suggested HVAC power. This was a couple ventilator fans over a very hot kitchen. So the temperature is getting very high, and the belts were more or less melting into the ships. So when they replaced it with HVAC power, they went from 3 to 4 having to visit these restaurants every 3 to 4 weeks to swap out the belt to they be able to make it a full year. So it saved them a lot of trips, and it saved them money on that annual contract that they had. And I guess that kind of completes it for the presentation. This is more for questions. But
Sure.
Before that, Lynn, you can go over your information.
Yes, thank you, Matt, for the informative presentation. The Dreisilker team is here to support all of you. We have 5 locations in the Chicagoland area and 1 in the Atlanta, Georgia area. Our counter reps are available to help with any belt questions you may have. We keep a large stock of V-belts at each location and have the ability to pull inventory from Optibelt's warehouses. We also have our website, shop.dreisilker.com, which is an easy way for you to check price and order V-belts. So that's it for our presentation today. Tomorrow, we will be sending an email with a link to the recording of this webinar and also a brief survey so that we can learn how we did and how we can improve future informational webinars. All right, so we will now open it up to questions for those who have them. Thank you for your time today. If you have a question, you can either raise your hand. It should be on the right next to your name, or there's a chat box for you to type in your question. We do already have a question from somebody, and the question is, where is the chart for the OptiCrick proper tension? We actually do have the spec sheet on our website, so if you go to shop.dreisilker.com and you type in OptiCrick and you view one of the gauges, it is in the downloadable resources on that page. So if you're in ever need of the chart, you can find it on our website.
Yep. And that was when I was talking about that. Comes with the OptiCrick. That's if you're in a pinch and you just need a number. So it's good to know.
I'll go ahead and I'll unmute everybody, and if anybody has a question, you can speak up right now. And we do have a question from Zach. Is there a tension difference between the cogged or standard belts?
There will be slightly, because tension is determined by tension will be determined by the power capacity of the belt. So getting very technical into it, there will be a slight difference, but will you be able to manage going from wrap to cogs? Yeah.
Okay. Great. Are there any other questions?
Okay, so you need 2 POs?
Okay.
Or do you already
Well, if there are no more questions, we'll go ahead and end this webinar. Thank you, everybody, for your time today. If you ever come up with another question about V-belts, go ahead and reach out to us, and we'll be happy to answer them.
All righty.
All right.
Well, thank you for your time.
Well, thank you very much. All right, goodbye.